I'm Charlie Stanier. I'm an associate professor in chemical and biochemical engineering at the University of Iowa.
I'm Scott Spack, assistant professor of urban and regional planning at the University of Iowa. So my son has always asked what it is that I do. He's 4.5. Then he was watching the Magic School Bus last night, and it was a show about climate. I was able to say, that is what I do. That's what I study, and specifically, how do we change what we do to respond to how climate works and to affect how we navigate a world in which we have a major role in climate.
So sometimes when people look at climate data, or any data, you look at a graph and you don't think, where did the data come from? We have the privilege here at the University of Iowa to work with NOAA, the National Oceanic Atmospheric Administration, to help run this high accuracy greenhouse gas monitoring station in West Branch, Iowa. And so it's been running for 10 years. Every afternoon there's a glass bottle that gets filled with gas, and that gets analyzed for about 70 different species that are important to the atmosphere and climate. So 10 years, one sample a day, that's 3,600 some samples. So when you look at a graph of that, it's 3,000 little dots, and it looks like a line, and you can see each winter and each summer, each data point to me has a story of somebody worked hard to do the engineering and the getting that data point. And they do it because they want to understand how this climate system works. So I don't quite tear up when I see that signal, but I do have that warm, fuzzy feeling of that was a lot of work to get all that data. Well, in talking with educators, one question that is really on their minds is, how do we know the balance between the natural drivers of climate versus the man-made drivers? That's been the major question that the scientific community has been trying to answer for the last 30 years.
And so we put together these global climate models and asked with separate simulations, what happens if we only look at natural forcings, volcanoes in the sun? What happens if we only look at human forcings from fossil fuels, from agriculture? And what happens if we put them together? And it takes putting them all together to resolve, to estimate the variability that we've seen in real life for the past 150 years.
So when we say climate, we're talking about millions of different variables. And so when you ask, is a model good at representing what's happening with the climate, it's not just like checking one thing.
And so the basics of physics and chemistry that we learned in those classes help us to connect, to understand how the Earth system works. And it took building up from the basics of, well, the basics of the Magic School Bus in terms of like atoms and gases and particles, and then building it up into climate, where by I think season 7 he now knows enough to understand what it is I do. This is at 8th grade. You know, you've gone through the first few seasons of Magic School Bus, and you've put together what it takes to be able to start to grapple with big systems like the climate system, and to combine these all with your scientific method to be able to grapple with this big system.